Hey, hello everyone. Good morning and welcome to the GDC GalaChain Hackathon. So today we have a 24-hour hybrid hackathon event encouraging both people in person and virtually to participate. And this is where innovators and developers come together to explore the possibilities of blockchain technology while leveraging the GalaChain public SDK. Now, thank you all for coming. This is going to be great. Can't wait to see what you guys all have for us. Now, the schedule today, we're looking at March 20th. So, as you all know, it's started as of now. In-person presentations. You guys are going to send us 5-minute recordings and highlights of your Hackalicious projects. After that, let's see. After the presentations and recordings have been reviewed, the finalists and winners for the judges' choice will be announced, and then after GDC, all the entries will be evaluated, and the winners will be announced in the GalaChain announcements channel in our Discord. Now, rules, there aren't a lot, but there are rules, the same rules we use in our Discord and in our end user license agreements. So pretty simple, no warranties on the software of any kind, and be kind. We reserve the right to kick anyone out, but just be nice to all the developers, and that shouldn't happen to any of us at all. Now, there are going to be celebrity judges, as you guys have known, following in Discord, and also in our Gala socials. You guys already know who they are, so they're going to be some of the biggest names in games, Web 2, Web 3, and music, so get ready for all of that. Now, winning criteria. To be considered the winning team, you're going to have to use our public SDK, present your project, and meet all the judges' criteria. Now, what is the criteria, you ask? So it's going to be based on usability, market potential, business value, innovation, technical application, and presentation. So for prizes, as you all know, there's going to be quite a few prizes, okay? And it's going to be a share, well, sorry, not a share. It's going to be $1 million. All right, quite a big prize, and we've got some NFTs to give out. Now, if you don't win, don't worry. You're still going to go home with a participation NFT. That's pretty awesome. So that is still something to look forward to, something to commemorate the time that you had here. Now, with judges' choice, what category is that? So this is going to be dependent and evaluated by our panel of celebrity judges. And the winner is going to receive a chunk of our $1 million prize. Now, judges' choice winners are still eligible for the open and game track prize pool. Now, to win first place, prizes are $200,000 USDT, 25,000 VGX tokens, 10,000 AWS credits, and a $400 Alienware monitor. In second place prizes, we have $150,000 in USDT, 15,000 in VGX tokens, and 5,000 in AWS credits. And in third place for prizes, we have $100,000 in USDT, 10,000 VGX tokens, and 5,000 in AWS credits. So that is something to look forward to, all right? That is quite a big prize pool, so get on it, guys. Now, to get started, make sure you guys have read through all the instructions, okay? There is a link, I believe, and it should be under hackathon.com latest/hackathon-deployment. I think it should be all there in your guys' packages. If you have questions, you get stuck, and you guys are here in person, look for an engineer. They're going to go ahead and help you guys. Now, if you are at home doing this virtually, we're going to need you guys to make sure you join the GalaChain Discord Hackathon channel. If you guys have questions, reach out to anyone there. They're going to be able to help you, all right? Other than that, once all of this is completed, to complete your submission, you're actually going to need this to be submitted by your team lead. So it's going to be Your choice of competition track, open or games track, your team and project name. And then you're gonna need to submit either both, public link and a slideshow, or a public link to a presentation, okay? And then link your Git repository, and then a brief description of your project. Now, after the end of the hackathon at 11 a.m., March 21st, judges are gonna review the submissions, and the judges' choice winners are going to be selected at this time. Now, a few days later, after that, entries will be looked at all over again, okay? They're gonna be scored, they're gonna be judged, they're gonna be reviewed, all of that good stuff. And then you guys are gonna receive feedback on all of your submissions. And then once that is all done, the submissions will also be shared on YouTube, on our Gala Games channel. Other than that, I think that's about it. So, with that being said, good luck to all of you, and let's get her going.
Hey guys, sorry I'm late. I got stuck in traffic doing the traffic thing. She has covered all of the critically important stuff that you guys need to know, so I just want to thank you all for being here, for putting together some awesome stuff that I know we're going to see over the next day or so. And I look forward to seeing all of this come out. There's going to be some awesome prizes up for grabs for everybody here. So hack away, and let's see what you can build on GalaChain. So thank you guys very much. And we would like to bring up our representative from AWS. Come on up and introduce yourself, and let's see what we got going on.
Great, thank you.
With a spin off the glass and a glinting
Yeah.
All right, let's see.
arms embrace in the Gilded Mansion. Solve the case. Step into the past.
Great, sorry about that. My name is Trenton Poe. I'm a senior solution architect for Amazon Web Services. I focus on AI, ML, and analytics, specifically in games, and wanted to really just introduce you to some ideas behind generative AI, what generative AI is, how it can be used in games, and more importantly, to try and overcome some of the fear, uncertainty, and doubt that we see in the industry around generative AI, to really capture the passion behind how it can actually help you as developers pretty much and essentially make much better games. So I'm not going to focus on the negative. I'm not going to talk about the importance of generative AI in the game space. What I'm going to focus on is showing you examples of how you can use generative AI to make your game development lifecycle a lot easier. But before I do that, I have to also introduce AWS, and I also have to, for those in the room who don't know what generative AI is, give you the standard introduction to what we call foundation models, and really these are the core components of generative AI. So for many of you who know what machine learning is or artificial intelligence in games is, we typically develop state machines, we typically develop decision trees, but there's another facet to AI, and that's called machine learning, where we essentially take a lot of domain-specific data and train a model in order to make predictions against that data. Generative AI or foundation models are an extension of machine learning in the sense that these models are very, very large, and they've been trained on exabytes upon exabytes of information, preferably Word documents, text documents, anything that has a sequence of different words to sentences to create meanings. And because they've been trained on such a large corpus of text data, they sound very intelligent. And so when you ask, say, something like ChatGPT a question, what's really happening underneath the hood is it's chaining together a sequences of words that it's learned, or the patterns behind those sequences that it's learned in order to complete a full sentence along the information that you've tasked in the question. So I want to sort of alleviate some of the concerns that there may be in the room around generative AI. Generative AI is not our new AI overlords. They're just really awesome machine learning models that have tons and tons and tons and tons of information that allow you to adapt it to most domains. The key thing too is that at this point in time in the industry, we find that there are a lot of generative AI use cases that focus on what we refer to as text-to-text or text-to-image. So what that means at the end of the day is that you type in a prompt to say, summarize this document, or give me a script for 2 people going fishing, and it will generate that content. Alternatively, there's also what we refer to as text-to-image models, where potential artists or 2D artists in the studio can say, give me a pencil sketch of a rabbit driving a sports car. And it will actually generate that image in the type of style that you want. And it's really robust in that example, in that it can also accommodate different types of styles like photorealistic or pixel-based style. So it's really amazing as to what the models can do and the content that it can generate based on pure text. So how do we position this? And from an AWS perspective, we really see that there's 3 types of users of generative AI. At the bottom is what we refer to as model providers. These are the open AIs, these are the Ray developers, these are the people who have large quantities of really powerful compute clusters. We're talking, thousands upon thousands of GPUs, and they have some really smart people who actually create these transformer-based or attention-based neural architectures that incorporate these models, and they have the exabytes of data that is used to train these models. And they basically build these models. It can take anywhere, depending on the complexity of the architecture, the amount of data, and how often they train it and experiment it, anywhere from 3 months to potentially 18 months to build these models. And the result of these models is that you have a piece of data that is normally about 12 to 36 gigs in size, and that's just the model architecture itself. The parameters or the coolness, the intelligence that makes up that model is also another potential 12 to 24 gigs in size. So to run these models, we're looking at a GPU with a minimum of 24 gigs just to actually make inferences against the model. So these model providers, this is their expertise. They have the resources, they have the intelligence, they have the data that can build these models. On top of that, we see tuners. And what tuners do is that they basically take the models from the providers. They don't necessarily have the big compute clusters. They don't necessarily have the super smart PhD people that formulate these models, but they have really good domain-specific data. So for an example, we'll take a company like Stability AI. They have a really good model, but they also have some really good image data. So they would potentially fine-tune an existing model, making it more focused on the type of domain, in this case, images. So essentially what they do is that they tweak the model or optimize an existing model to make it generalizable to a very specific type of topic, or what we would refer to as a domain. The last persona that we see is really consumers. These are people like you and I, and hopefully what we'll be doing over the next 24 hours is utilizing either the foundation model that the model providers have created, or a tuned model that the tuners have created, and we're going to use that to execute XYZ function, to basically generate text, or basically generate art assets, and in certain cases, depending on the model and the provider, we can generate music, we can generate 3D images, and we can also generate video. So from an AWS perspective, and I've only got 2 slides about AWS, so I'm not going to bore you with marketing spiel, but essentially we have adapted our base set of services that provide generative AI capabilities to our customers around those 3 types of personas. So if you look on the right-hand side of the slide, we have the capabilities, the compute resources, the clusters, the services, the ability to actually build, store, and train these large language models. So we have the infrastructure and the services to address the requirements if you're a model provider. And some of the models that you see in the industry have been built and trained on these AWS infrastructure resources. If we go one level up, if you're going to be a fine tuner or potentially a consumer, we have services that address the specific requirements for you to take an existing model, say like Meta's Llama 2 model, and tune it around your potential domain data. So I'll give you an example. If you've got reams and reams of fan documents around your game, you might actually take an existing model, say the Llama 2 model, and you might fine-tune it with that fan-based information to customize the model to answer around the particular lore of your game. Fine-tuning a model does not take 3 weeks, 3 months, or 18 months. Depending on the size of the data, it can take potentially 6 to 12 hours, maybe a little bit more, to fine-tune. So the beauty of that is that AWS gives you dedicated services that allow you to become a fine-tuner without having to actually run the compute environment and have access to those super smart people who are capable of architecting and building these large models. And then lastly, we have the ability to actually use dedicated services to complete a job. So for instance, as an example, if you're writing code for your game and you're writing it in Rust and you're not that familiar with Rust, maybe you're not a polyglot who's got Rust experience, well, you can use these code generation capabilities that we call Code Whisperer to help you write some Rust functions or to write some C++ functions. Alternatively, we also have Amazon Q, which is essentially you can create your own chatbot and give it access to your on-premises data or your websites or your SharePoint documentation or your Confluent wiki, and it can actually use that as a knowledge source to help you answer questions that are specific and proprietary to your use case. The other thing that AWS also provides is we take governance, security, and what we would classify as responsible AI very seriously. So what we try to do is we are trying to circumvent the unnecessary fear, uncertainty, and doubt within the industry around generative AI. And we're trying to lead with the respect that if you use any of those aforementioned AWS services, we don't ever see the data that you send to the hosted model. We don't ever see the response from that hosted model. And if you do incorporate knowledge bases and knowledge sources, you own those and they're proprietary either on your on-premises environment or sitting within your virtual private cloud component of your AWS account. So what that means at the end of the day is that we never use your data to enhance our models. We don't even see how you are actually utilizing the models. We also take it seriously to the point where the models that are Amazon branded, and I'll talk about this a little bit later, but these are what we call our Titan models. So these are foundation models that we have created within Amazon. We have models that allow embeddings. I'll talk about that a little bit more, but text to text as well as text to image. We can guarantee that the sources for that accumulated to that training data are sourced responsibly by AWS. It's our internal assets as well as publicly available assets. And we can also trace down to the individual piece of data that was used to train our models, to the point that if you generate any information using our models and someone turns around and says, hey, that image that you used in your game, well, I developed that and I put it on Getty Images. AWS, if you used an Amazon Titan model to develop that image, we will actually go with you to court, bring our legal team, and actually show proof of the fact that that particular Getty image was not used in Titan training. So we take it very seriously, we take the usage of it very seriously, and we also have implemented steps to protect you as our customer when you use not only our services, but our custom-built models as well. All right, enough of the marketing speak. Let's talk a little bit about how we can use generative AI in games. So when we start looking at those three types of personas, we really see that the consumer persona is going to be you as developers, as studios, whether you're an indie, whether you're a AAA, or whether you're, as I'll show you later on, someone working on a weekend to develop a game. We basically classify three types of use cases. And I'm going to show you examples of this as we go through. The first one is really publishing operations. Consider this studio operations. This is generally, how can I use generative AI to create assets that are not specific to the game, like cool posters for my marketing campaign. Or another example might be, help me generate a quick website with some really cool pictures, because I'm a game developer, I'm not a front-end web developer, and I don't have time to do that. My core focus is building my game. So let me focus on that and give some key instructions to a generative AI model to help me build my website. What that in effect does is that means that I have saved time, energy, effort, and resources to build an important aspect of my studio, my website, without detracting from the thing that I really need to do, and that's build my game. So as you'll see through these use cases, the message that I'm trying to leave you with is that generative AI, in many cases, enables you to get jobs done faster by taking care of some of the important tasks that you don't have to focus on, so that you can focus on actually building your game. The next set of use cases that we have specifically for the games industry is for game development. So think about this as generating 2D, 3D, potentially video content using generative AI that you can use inside your game. Another one can also be potentially generating script ideas. Last year at GDC, I was privileged enough to attend a discussion from Ubisoft's LaForge, where they have a whole team of infrastructure managers, and they use generative AI to help their script writers come up with new ideas. So to overcome writer's block and key in a couple of key aspects that they wanted to see, and actually have generative AI generate the idea or the content around that script, giving them a starter to sort of build on because they're fresh out of ideas. So, not only are we looking at 2D, 3D content, but also textual content as well. Sorry, meeting request. let's dive into some of those examples. So the first one is 2D content. I'm going to caveat and say that 3D content is available, but it's very, very new in the industry. 2D content is actually very mainstream at this point in time, and you'll see that you can actually type in a few keywords to generate a concept of a 2D representation. The example that I have there, I actually generated this morning. The prompt that I used was an imaginary car that can also be used as a boat. And after a couple of seconds, I actually had this image. Now, is this something I'm going to put in my game? Probably not. But if I'm trying to come up with ideas for my game where I need a boat, car, plane hybrid, well, this is a starting point. And I can take this and use it effectively as an idea to build upon, change the colors, maybe rip it apart. And maybe I can also do some really cool features around it by enhancing certain capabilities, maybe shrinking it down and generating more of a background that fits within my world. And all I have to do is basically text what I want in my prompt, and the image is going to come up accordingly for that. The other thing is also character development. What you'll notice here is that there's 4 different characters in certain scenarios, and each of these scenarios I've used basically the same prompt, but I've changed a couple of words. So for example, I used, character design and says make a raccoon person. The next one is make a cat person, but the next one is also use a cat person, but I want a sword instead of a gun. And the last one, I want to keep the sword, but I want a frog person. So the point I'm trying to highlight here is that let's think about what goes into building a frog person, a cat person, a raccoon person as a 2D artist in the studio. I've got to start from a blank canvas, and I've got to come up with something, and then I've got to go and color it in, and then I've got to go and give it a sword or whatever. And then I realize that part of this character guild, I also need frog and I also need cats. So I've got to literally start from scratch and rebuild those characters in the same style that I built the raccoon character. In this scenario, all I've done is use the same prompt, but I've changed a few things around. And what has happened is that the image generation model has kept the style, but it's given the different attributes that are required. And all I've done is change a few words in the prompt. So effectively, I have 4 different characters in a similar style, but are unique, and it's taken me probably about 7 minutes to cut and paste different parts of my prompt, click enter, and get it out. So the point, once again, is that I've saved a considerable amount of time giving me assets that I can build from, that I can start from, instead of taking a white canvas and starting from scratch. The other thing that's also important that we see a lot of customers use generative AI in the image space is actually to enhance the resolution of much older assets. So typically, I don't know what it's like in your scenario, but some of the studios that I talk to have assets that they've used once in one part of the game, and it's sitting there on some file server somewhere, and no one's ever used it again. Until someone says, hey, you know what, we're doing a refresh, I need those existing assets, but you're really not up to speed with the kind of 4K or 8K capabilities of the new version of the game. So we can actually, instead of going through a lot of tooling to update the update the image, we can actually use generative AI. And there's certain models specifically that are in the space from Stable Diffusion hosted on AWS that we can actually send the image, tell it what we want, and actually have it upscaled, change the resolution, and do all of that task by entering a few keywords as opposed to actually going through and doing it ourselves. One other example, this may not appeal to you, but it's something that we found was quite interesting, so we actually went and we built a solution around it, is giving your users the ability to use generative AI. So not only are you using generative AI within the game development cycle, but you're actually now extending that to your users, where a user can actually upload a minimum of 6 to 8 different photos with different sort of scenarios, one with glasses, one without glasses, but you'll see there in the example it's fairly similar style of photos, but then using text prompts to actually build an avatar representation of that photo, and to the point where they can actually change not only the style, but add certain things, you know, like I want him to look like Iron Man kind of thing. So this is a feature that you can actually see was built on AWS, and it is completely downloadable and accessible to run in your own AWS account. So the code assets are available on GitHub, and you can deploy this in your account and actually extend it ready-made out to your user base if you want to give them the option of generating their own characters. 3D assets, as I said, are a little bit more complicated. There are models out there that can also give you 3D assets and even animate those 3D assets, but they are very new at this point in time. Sometimes a bit buggy. It's not exactly mainstream. However, there are a number of methods that we can use generative AI without having to leverage some of these newer models to generate and create 3D assets. We refer to this as an inference pipeline, where effectively we use generative AI to create a 2D asset, and then we use another machine learning model hosted on AWS that will either do Gaussian splitting or neural random fields, where we actually change the shading of that 2D image and create a 3D representation. So we're not building the 3D asset completely through generative AI. We're using multiple or 2 different machine learning models, one generative AI text to 2D, and then one 2D to 3D image as an inference pipeline. So is it possible to use these mathematical techniques without having to build a 3D model? Absolutely, on AWS. And then lastly, the last example, I touched on this a little bit, where we talk about text-to-text assets. One thing that I've seen customers really like is that if they're moving from one platform to another, is to actually summarize their help screens to a different playable format. I'll give an example. If you've got a PC game and you're taking the game and you want to make it run in mobile, you normally have a help screen that has a considerable footprint on the screen, and that footprint doesn't condense when you move to a mobile platform. So what you could effectively do with generative AI is to take the context of that help screen and say to the model, capture the semantic meaning, but summarize this in 3 bullet points as opposed to the 30 paragraphs of my help screen. And then you can actually see the results and see if it will actually fit, because it will certainly be smaller as it fits into a smaller platform. But think about the time and energy that goes into taking just a help screen and rewriting it, but making sure that you capture the important information that a user would need in that help screen. That can take maybe a day, maybe a little longer, and now you're getting that portable capability to your mobile platform in the space of maybe 30 minutes, because I still recommend that you read through and make sure that those 3 or 4 bullet points that come out are still syntactically correct and they actually make semantic sense against what the original platform was. All right, so I am going to show you a demo, because typically what we do is that we talk about PowerPoint, but I want to prove to you that this is very quick and easy and simple to use, and then give you show you what can potentially happen for you if you want to use generative AI over the next 24 hours to help generate certain assets for your game. So first example here, I am going to use a generative AI model. It's called Amazon Titan image. So the first thing is I know, firstly, that I'm using a Titan image. So any image that I generate is not taking anyone else's data to train that image. And I also know that Amazon will step in and help indemnify anything from this image. Another thing that I didn't mention is that any generated image from Amazon Titan has an embedded watermark. So you can also verify it against your AWS account to check any image, was it or was it not generated by Amazon Titan Image Generator. So it also gives you the ability to reversely check if you outsource a lot of art to the community and they say it's original and you're paying for it, you can also then check it against your AWS account and the Bedrock console to see if it was actually generated by Bedrock or not and whether or not it's authentic. So I'm going to give you an example that I typically give to customers when we generate 2D art. I'm going to say, you know, give me a bunny, sports, car. And what I also like to say to artists is add pencil sketch as an option in your prompt. The reason I say this is because think of this generative AI model as a junior artist. If you hire a junior artist over the summer or even an intern and they create some art for you, you're not probably going to put that asset into your game. You as the senior artist are probably going to take that asset and you're going to change it, maybe change the colors, maybe delete a few things, and you're going to make it more, better to suit your game and the passion and the idea that you have inspired by your game. So I like to tell customers, you know, if you're going to generate an asset, add the word pencil sketch behind it, because what that's going to do, it's going to kind of give you something that maybe a junior artist would spit out, or maybe an intern would give you over the summer. And it also, you know, gives you the idea of what you can potentially use, and how you could then now customize it and add colors. So this is a very, very basic example. I am not an artist. I'm also not a really smart prompt engineer, but this shows you an example of how I've just used a website, added what I want, and now probably about 8 to 10 seconds later, I have something that I can download and start adding color to and working. Previously, I mentioned certain things about image enhancements and in-painting. Here's an example of what we can do. So for instance, if this is an image that I've created, I can upload it to this website, and I can say, you know, I like the car, but I don't want the car in front of the garage. I basically want the car at the beach. Now, I don't know why we'd want a car at a beach, but this just illustrates how the model can imply a masking capability where it will mask out the car, and then it will generate a brand new image and then superimpose the mask on top of that brand new image. So basically, I've taken an existing asset and I've completely reused it in a totally different scenario. And as you can see there, it's taken me 8 seconds to do. So instead of having to come up with a beach environment on my own as an artist, I've just generated it. The last one I want to show you is image extension. So if we have an existing asset where we want to now zoom out and make it more aware, say in our world, I would have to take this car, I'd have to stretch it out, I'd have to make sure that the resolution works, but then I'd also have to build the rest of the scene around that. So in this scenario, I can say I've got a car, I want to keep the car, I want to position it in the center, and I want to keep it in the middle in both horizontally and vertically. And what this effectively means is that I want to shrink the car and generate the rest of the image around it. So instead of having to go through that capture mechanism, shrinking the car, and then having to rebuild the whole image around it, I put these parameters into the Gen AI model, and maybe not 8 or 10 seconds, I think that was about 15 seconds, I now have the exact same picture zoomed out, and the model has automatically generated the rest of the Christmas tree because I specified that it's only the card that I want to keep, and I specified its position. So if we think about that, I've just performed something that could take quite a few minutes, maybe even a couple of hours in the space of 15 seconds. And this is just really a narrow example of how we can create 2D assets for our game, or generate concept and ideas, image ideas for our game. And the point that I want to drive across is that, notice I'm not reinventing the wheel. I'm performing some function and task of what a typical artist may do, but I'm taking a lot less time to do it. And what that effectively translates to is that if I'm saving time, that's more time and energy and effort that I can spend to other parts of my game development. Okay, so the last category of examples that I'm going to talk about is actually using generative AI in a game. And I, unfortunately, because of not having my laptop connect up to the video, I can't actually show you the NPC dialogue example. But you're welcome to come over to Moscone West for those of you who are actually at GDC. She's running there. But effectively what I've done is that, as an example, I've downloaded one of the samples from Unreal Engine MetaHuman. So I am not a game developer. I'm certainly not an artist. I lack the imagination. So I took an example of a MetaHuman, and all I did effectively is, instead of building the script for her dialogue, I hooked her up to a solution that was deployed on AWS. And I will, if I can get it right, show you here. This is an architecture that was designed on AWS, and it is also freely downloadable on GitHub if you want to run it in your own AWS account. But effectively what I've done is that I've exposed a really complicated language model called Anthropic Claude. It's one of the better, more performant models that are available on the industry, and certainly available on the Amazon Bedrock platform. And I've exposed that as an API to my MetaHuman in the game. So effectively what I've done is that I've given my MetaHuman, or my NPC character's dialogue, is going to be generated automatically and dynamically. Now, if we step back and think about this, if I've got an NPC, I have to script the dialogue for any player interactions for that certain part for that NPC. But if I really want to make a super cool game, I'm going to have to create multiple decision trees with different sets of potential dialogue that are dependent on what my player might do to interact with my NPC. And then what I also want to do is that, because I want to avoid player fatigue through a certain playthrough, that if a player potentially has to respawn and go talk to the same NPC again, I don't want the NPC to say the exact same thing. I want to improve the experience, so I want to make the NPC say the same thing but in a different way, so that the player feels like it's a brand new interaction with the NPC. To do that in a game can take weeks and months, not only for the static dialogue, but also the various potential scenarios, and then also having different versions of the dialogue to up the quality of the interaction. So using this scenario, what I've effectively done is that I've given the NPC the ability to have her dialogue generated dynamically. So what that means is that anytime a player interacts with the NPC, the dialogue, or the interaction for that dialogue, the response to that is going to come from a generative AI foundation model. The problem with that is that, how do I train, or how do I tweak one of these foundation models to be consistent with the NPC in my game? So there's a couple of ways that we can do that. Using Bedrock, as I said, we can actually become tuners. So we can take the foundation model provided by Bedrock, we can add our game lore, and we can spend 6 to maybe 12 hours to fine-tune that foundation model around our game lore and have our own version of Claude that's been optimized to our game lore. That's one way we can do it. Another way that we can do it is to use a technique called retrieval augmented generation, where what I could do in, say, maybe 5 to 7 minutes is upload my game lore into a database, into a knowledge base, effectively. And I can spend a lot of time afterwards if you want to know how we do that, but essentially what we do is that we augment the request to the model with our game lore. So as I, as a player, am interacting with the NPC, before the NPC answers, or before that that dynamic response is coming back from the Bedrock model, it double checks it against this knowledge base, uses it as context into the request, and responds accordingly with that background information as part of it. So what that effectively is going to do is going to give you an NPC who understands what's happening in the game by spending 5 minutes to upload your game lore content, text knowledge content, into a database. And that way, we can actually now overcome weeks, potentially months, of dynamicizing our script writing to make it actually work with our NPC. The last example I wanted to show you is a game that was developed in a similar scenario to this. It was a hackathon that was run at AWS. And over 2 weekends, a single developer used the Bedrock service, and he used it to generate text script, and he also used it to generate images, and he created a game called the Gilded Mansion. And I'm just going to turn on the sound here quickly. But this is a completely playable game that is available online on the web, and he's using the web as his mechanism to interact with these players. But basically over 2 weekends he created each character in a noir format or a noir style, and he also generated the dialogue, and to the point that he also now hosts it on AWS. So when you actually click into the game and get started, the interaction is using the game-specific services like GameLift, integration with the game to kind of host the game as well as develop the game on AWS. And the beauty of it is that he is not a programmer. He is not a game developer. He's actually a support engineer in one of our data centers, and as part of the hackathon, he built a game because he has a passion for gaming. So I thought that was a unique experience to show you, because he literally did what you're going to be doing over the next 23 hours or so. So lastly, a couple of things that I just wanted to highlight before we close up. But to do studio operations, we have a unique service called Amazon Q. And with Amazon Q, you can point Amazon Q to your on-premise data. You can have it go and scrape websites. You can integrate it to GitHub, to Confluent, to GitLab, and you can have it go and index that information. And in the space of 5 minutes, you can create your own chatbot. So if you want to enhance studio operations by injecting a code-capable development chatbot to your developers, or just to say, I don't have time to hire HR resources. I'm a game developer, so we can actually put our HR resources in our wiki and expose it via a chatbot. And within 5 minutes, you can also extend that chatbot potentially to your players instead of having a support center. So there's a lot of other aspects to just running your business whether it's games or healthcare, life sciences, or financial services, that generative AI can augment and help. And even, just as I created a database with, potential game lore as a knowledge base, I can also create a database of all of my image assets, and I can also go and use text analytics to go and find those image assets, or actually make really cool presentations based on our game analytics data. So I wanted to thank you very much for your time. I know you've got a lot of work to do over the next 23 hours. I also wanted to thank Gala for giving us as AWS the opportunity to sponsor and also to present generative AI to you. I wanted to just sort of say that if you have any questions afterwards, I'll be available to answer any questions. And one last thing before I go.